So I'd like to finish off a few examples on solving rational equations. We've already done some of them. And when we cleared out the fractions after stating the restrictions, we were left with pretty simple equations to solve. Okay? There may be times, there will be times, when you clear out the fractions and there will be a quadratic equation left. And you guys should know how to solve quadratic equations, usually by factoring, sometimes by plus minus square root, but usually by factoring. So let's have a look at D. What's the first thing I'm going to do? Sorry? Okay. So what can't X be? Okay. Very first step would be to see if we could factor any denominators, but this one we can't. So we go right to the restrictions or the non-permissible values. Now what? And what is the LCD? 4x. It's got to have a 4 in it. It's got to have an x in it. So 4 times x. So everything gets multiplied by 4x. Everything, including the non-fractions. Like so. And why do we do that? Because then we can cancel out all the denominators so they disappear. That's why we multiply by the LCD. Because we don't like fraction equations. So I've got a 4x up top and a 4 on the bottom. Well, the 4's cancel out to 1 and 1. And I'm left with x times x, x squared. Right away, as soon as I see that, I know, oh, I got a quadratic equation to solve. Minus, what cancels out here? The x's. So I'm left with 4 times 7. 28. No canceling going on here. It's just 4x times 3, which is 12x. Yep, we got to move everything together. So we got to move the 12x over to the left side and put it in the middle. So we get x squared minus 12x minus 28 equals 0. It's one of those trinomials where we have x and x at the beginning of each binomial. And remember, so with these ones, we're looking for two numbers that add to negative 12, but multiply to negative 28. Don't think of numbers that add to negative 12 and check the product. Think of numbers that multiply to negative 28. It's easier, trust me. There's fewer choices. So what pops out at you? Okay, so, I mean, like when I first looked at it, I thought 7 and 4, but no way 7 and 4 can make 12, negative 12. So yeah, I got to look for another pair. So 14 and 2, and it turns out to be negative 14 and positive 2. So what are my two solutions? Whatever value of x makes this 0, which is 14. Whatever value of x makes this 0, which is negative 2. Check those against the restrictions. Both are good. This one. First thing, any factoring? No, nothing to factor. But keep in mind, whenever we have more than one term in a numerator or denominator, remind yourself that they have to stay together in parentheses. So we can go straight to the non-permissible values or the restrictions. X cannot be 7. So what is the LCD? I need an x minus 7 in parentheses, and I need a 2 in there. So we write it like this. We always write the number in front of the parentheses. So that's my LCD. And I got to multiply it by this, plus the LCD again, multiplied by this, equals the LCD again, multiplied by the last fraction. The denominators will always cancel out if you choose the LCD correctly. So what can we cancel out here? So I'm left with, and I'm not going to multiply this yet. I'm left with 2 times 2x minus 9. What cancels out here? The 2. So I'm left with x minus 7 times x. So whenever we have a binomial times a monomial, a single term, we always write the monomial first. So I'm just going to reverse this order here. And right away I see this is going to be quadratic because when I get rid of that second set of parentheses, I'm getting x squared. This one's pretty straightforward. What can I cancel? And I'm left with 2 times 5. 10. So we got to simplify the left-hand side as much as possible. First thing we do is get rid of the parentheses. 2 times 2x minus 9 is 4x minus 18. Plus x squared minus 7x equals 10. Well, 4x minus 7x is negative 3x minus 18 plus x squared equals 10. I got to bring the 10 over, and then I got to put it in proper order to factor. So what term goes first? The x squared. Then the minus 3x. Then the minus 18 and the minus 10 when I bring it over. Negative 28. We got another one with 28. Yep, but one's got to be positive, one's got to be negative. Positive 7, negative 4. Negative 7, positive 4. Because they have to add to negative 3x. Therefore, my two solutions are x equals 7 and negative 4. Any problem with those? Yep, that's a non-permissible value. That's a restriction. I can't have that as my answer. So there's only one solution in this one. Okay, this last one. Well, that, remind myself, any factoring? Yeah, the last fraction of the fraction on the right-hand side. Two numbers that multiply to positive 18, but add to negative 9. Minus 3, minus 6. which just happen to be the other denominators. That happens a lot. Now, what can't x be? 3 and 6, so I got to make note of that. And now the LCD. X minus 3, x minus 6. Yes, this looks like a very big step. Once you get past this one, bless you, bless you. The nice thing is, it looks like I'm not going to have a quadratic in this case. So what cancels in the first? X minus 3, so I'm left with 9 times x minus 6. No x squared there. X minus 6 is canceled, so I'm left with minus x minus 3 times 4, but write it in the reverse order. And on the right, well, everything cancels, and I'm left with just 18. So no quadratic, no factoring involved anymore. Just got to get x by itself. So multiply through 9x minus 54. Be careful. This is the mistake. This is right here is where students will often make the mistake. Plus 12. Because you've got a negative times a negative. Equals 18. Simplify the left-hand side. Collect the x's, I get 5x. Collect the numbers, I get negative 42. Equals 18. Add 42 to both sides. I get 5x is equal to 60. Divide both sides by 12, or sorry, 5. And I get x equals 12, which is a good solution, yeah. No. Well, oh, I see what you're doing. Yeah, you know, it is possible to do it. It would be technically correct. Like if you went from here and you move the 18 over, you'd get 5x minus 60 is equal to 0. Well, I can factor this by doing GCF. Well, there's no variable here, but what value of x makes this 0? 12. It's possible, but I would probably avoid it if I were you. If you're comfortable with it, go with it. Okay, I mean, like I said, it's still correct. But it's not really something that we've looked at. Like whenever we've had just equations that have x in it, we haven't worried about factoring, even though it is possible to do with it. And that's it. We're not doing the last example. I'm not going to worry about word problems this year.